So this is from Gochifix. This is their Oscilloscope Multimeter. Now, it's a standard size multimeter. You will have to add your own batteries, if I remember right on this one. It's going to come with your standard multimeter probes, and they are going to have 600 volt category covers over top of them. So if you're doing some probing around on a circuit, you don't want to accidentally arc something, you can definitely do this by plugging here into the common. And then on everything, most all of your measurements are going to be done on this side here. So this is going to be your oscilloscope, voltage, resistance, capacitance, everything else. If you're going to check for amps, this is an amp meter also. You can go to milliamps on this side, 600 milliamp fuse, and 10 amps max on this side. But what makes this thing interesting is not just the simple DC power. So there we go, is it's got an interesting screen you see up there. This is where you're going to see a waveform if you're doing AC. And then in this case, it's going to have just a display showing you the voltage. So in this case, it's doing an auto voltage of DC. Doesn't have anything to show because we're not touching anything yet, but I am going to touch it too real quick here. I'm going to touch the probes to our battery and see if it concurs. And it's saying our battery is at 1338. So it's a little bit on its way up there. And that matches almost exactly my little power readout up here. This is the onboard power readout, and it's 13.41. When would you use an oscilloscope? Oscilloscope is really good for measuring voltage over time. That's why it's displayed usually in a graph. There's the waveform over time. To do this, I'm actually just going to plug this. And again, do you see that waveform? So it's actually doing the sine wave. Now I can change the voltage range here. So that's a 60 hertz sine wave pattern. And what's interesting about that is when we come to use our off-grid power system over here, I'm going to take this same tool that we have right here, and I'm going to plug it in to the inverter, and we're going to see what kind of power and waveform we get out of the inverter. So we've got a little bit of a different story here. So hopefully you guys can see that. I'm changing the range here, and you can see that is literally like a square. You know, so that is not a pure sine wave inverter. So that might be one use case where you could use this, is if you were testing the output of an inverter like this. It is a 10 megahertz bandwidth. So, you know, again, not the best, but not the worst. It's actually a little bit better than a 5, obviously, or a lower sampling rate. Really easy to see, you know. And then when you switch over to all of the other modes, so let's say ohms of resistance. So now if I just touch the two probes together, that's going to set off an alert. So it's 0. Now you could set different modes, it looks like here, if you want a speaker. So if you are measuring, there is a way to actually recall past waveforms. So you can store, I believe, up to 100 different waveforms. So if you're trying to diagnose something and you have it recording, you can actually record the waveform while you're using it. That's another really cool thing. Amperage limited to 10 amps, which is most handheld multimeters are going to be maxing out at that. I do think for the right person, this could be a really useful tool, especially on the go as a handheld multimeter.